So moving on to the first question of section 2. This is a multiple correct question. It can have more than one correct answers. So looking at it, it looks quite daunting, but it's straightforward and it's not really from any specific portion. For instance, the part D is option D is related to basic complex numbers, but the others are not essentially. So let's analyze every option. So first we have Z union T1 union T2 is a subset of S. Our set S is A plus B root 2. A and B are integers. So B can be 0. Thus S indeed has all the integers from this part A. So yeah, Z is a subset of S. Then T1, it's the set of all the powers, all the positive powers of root 2 minus 1. So obviously in its expansion we will have terms of the form A root 2 and A root 2 plus B only, because its expansion would be root 2 to the power of n minus nc1 and so on up to minus 1 to the power of n. So clearly all the terms would either be of the form A root 2, let's say A1 root 2 or B1. So adding all of them, we will have only this form of terms. So T1 is also a subset of S, and T2 is just replace minus by plus. So again clearly it would be of the form A root 2 plus B. So option A is correct. Now option B. To analyze option B and C, in fact, we'll first make a little observation. T1 is not T1 exactly, but root 2 minus 1 is less than 1 and root 2 plus 1 is greater than 1. So all the powers of this are between 0 to 1, and all of the powers there are from 1 greater than 1 actually. So all the terms in T1 are less than 1 and greater than 0. All the terms of T2 are greater than 1. As n goes to infinity, as root 2 minus 1 is less than 1, so as n increases, this root 2 minus 1 to the power of n decreases, and the lower bound obviously is 0. Limit n tends to infinity, root 2 minus 1 to the power of n is equals to 0. That means for some n, root 2 minus 1 would be less than any given epsilon of our choice, and choosing epsilon as 1 upon 2024, we get that for some n we will have this for some n we will have this condition to be true. So in fact B option is thus incorrect, because for some n which will be in T1, we will have, sorry, for some n large enough, we will indeed have that minus root 1 plus root 2 to the power of n is less than 1 upon 2024. So, and similarly we can argue here, as n goes to infinity, root 2 plus 1 to the power of n goes to infinity. So we will have some n naught such that root 2 plus 1 to the power of n naught would be greater than 2024. So C option is correct. So we will have some possible value of n naught for which this thing would be in T2 and this thing would be greater than 2024. So there would be an element in the intersection of these two, T2 and all the numbers, natural numbers greater than 2024. So far the options have been straightforward, and if you have some confusion in exam in option 4, you can easily skip because you will score partial marks by just analyzing first, second and third options. As to the fourth option, cos theta plus iota sine theta is equals to e to the power of iota theta. Here theta is pi a plus b root 2. So we will iota pi a plus b root 2, which is equals to e to the power iota pi a. This is some integer power of e to the power of pi iota. So this term will be either -1 or +1 depending on a, and the exponent in plus will become a product here, so it would become e to the power of pi iota to b root 2. For this entire thing to be an integer as given in the option, this is either plus minus 1, so this thing has to be an integer. So it can also be plus or minus 1, but that would need this part to be an integer. But b is an integer, so b times root 2 would be an irrational number. It cannot be an integer. So this is possible only if b is 0. So one direction is true and the other is straightforward. If b is equals to 0, then cos a pi plus iota sine a pi is e to the power of pi iota a, which is either plus minus 1 depending. So D option is also correct. So the argument was for this to be, as this is integer, for the whole thing to be an integer, this thing has to be an integer, and this can either be plus, it can only be plus or minus 1 depending on this. But for this whole term to be plus or minus 1, this thing has to be an integer, and for that we will need b root 2 to be an integer, but that's not possible if b is non-zero. So